And thank you all for joining me in the last talk of the day. I know you all want to go grab a beer or do something else. But first you have to listen to me rant about passwords for 45 minutes. Yay. Who here likes passwords? Is there anybody who likes passwords? You're lying. Nobody likes passwords. At least I don't. And in this talk, I'm going to talk about passwords, what they are, how old they are, and also if we're going to see if there's a solution to get rid of passwords on the web. But firstly, I'd like to introduce myself. Now it works. Hey everybody, my name is Bellen, not to be confused with Bell, one of the organizers. We have almost identical names, which is somewhat confusing, but this is me. I'm a senior developer advocate engineer at Auth0, and if you've never heard of Auth0 before, we're an identity as a service provider, which basically means that we try to make logging in and registering users as easy as possible so you can focus on building your actual applications and not keeping them secure. I'm also a Google developer expert, and you can find me on the internet as Sambego. Cool. If you'd like to follow along on your own devices, or if you'd like to see the slides again after this talk, they will be available at 1990.sambego.tech. So let's see what we're going to be looking at in this presentation. We're going to start with a little history of passwords, because they've been around way longer than I thought, and maybe you think as well. Then we're going to move on to certain different types of passwords, move on to passwordless authentication, and lastly, we're going to have a look at the Web Authentication API, which is a newer-ish API implemented in browsers that might get us rid of passwords. Let's get started. A little history of passwords. Somewhere before Christ. I have no idea which exact date, but somewhere before Christ, when the Romans ruled in these areas around here, they figured out that the Romans used passwords to determine friends from enemies. So if one legion of Romans would encounter another one, and they didn't know each other because, well, the Roman Empire was huge and they didn't know everybody, they would just say, do you know the password? And if they got the password right, they would go for drinks and wine and beer. And if they got the password wrong, you can imagine what happens, right? They would have to fight till the death or something like that. I don't know, I'm not a Roman. But passwords have been in use way before we've used computers. They've been used probably also before the Romans, but this is some fun fact that I found online, so I'm going to assume it's true. But it's just to illustrate that they've been around for a long time. If we fast forward a little bit, there's this one famous story of 1001 Nights or Arabian Nights, where you have this bunch of thieves that steal all the gold and jewels in the whole kingdom or in the whole world, and they hide them in a cave, and the password to open that cave is open sesame, right? If you said open sesame, the cave would open and you would be able to get to all the gold and jewels that the thieves have hidden in that cave. Cool. Let's forward a little bit to a bit more modern times, to 1961. And in 1961, an engineer called Fernando Corbato invented or co-invented the time-sharing system. Well, back in the day, not everybody had a phone in their pocket and a computer on their desk. They usually had one big mainframe in a university and a few terminals, which meant that not everybody could use the computers at the same time. So they invented a time-sharing system, and everybody could use their password to get their own piece of that time-sharing system at times. So the first time that a password has been used with a modern computer has been around 1961 at MIT. Now, if you fast forward a little bit to the 1970s, Robert Morris Sr., who worked at Bell Labs, invented hashing, which means that the first at least 9 years of passwords on computers, they were stored in plain text. Now, if there's something you want to take away from this talk, apart from I don't like passwords, please don't store them as plain text in your database. And then we fast forward to the 1990s, where hacking became more of an issue, just because everybody wanted to be on the web. The dot-com bubble was about to happen, and hackers saw potential in this. They saw, like, everybody wants to be on the web. Cool, we want to steal everybody's details, everybody's data. So hacking became more of an issue, and we had to take logging in and using passwords way more secure, we had to take way more care of those passwords than they used to do back in the day in the 1960s when they used passwords for the first time on computers. We're 2020, and we still use passwords. Who used the password today? I think I can just guess everybody. We all use passwords today. There's still the default way of authenticating on a device, on an application, on almost anything these days. But hopefully one day this will change. Yeah, makes me cry. So let's look at a few different types of passwords, because I've been telling you that we've been using them for a long time, but there's actually quite a few different types of passwords. And the first we have to define what is a password. And to me, a password is anything that's a shared secret. So if it's a shared secret between two parties, hopefully 2, sometimes more, that can be considered a password. And the most common one is a string. It's the one you use mostly daily to log into certain applications, certain services. It's a string. Hopefully it's not password 1234. Hopefully it's something more randomish, longer. Should be longer, more than randomish, so something like this is also often a very good password. And who knows this password? Nice. If you don't know it, it's from a KCK, I don't know how to pronounce the name, but from a comic. So look it up. And the good thing about these is they can be hard to guess by others, especially if they're long and randomish and complex, which means that they're hard to brute force by others as well. Nobody can just try to log in with your username and just go from A to B to C to D to any combination that's possible to a certain amount of length. It would take up too much time. But it also means that it's quite hard to remember for ourselves. I know 1 password, maybe 2. And that's because I use a password manager that helps me remember all of my other passwords. Who uses password managers? That's a lot of hands, makes me really, really happy. That's cool. So if you use a password manager, those pieces of software help you remember passwords, and usually just need a password to open that password manager. But if you don't use this, and people who don't work in IT or in tech often don't use password managers, they have to remember all of their passwords, which sometimes is also 1. Yeah, they can be hard to remember. The other one, the next one, is a PIN code, and we all use this also almost daily, maybe to unlock your SIM card on your phone, maybe to withdraw some money at an ATM, maybe to open the door of your compartment complex. The PIN codes are used in a lot of different situations, and they're often short, 3, 4, 5, 6 digits. And a good thing about this is, because they're so short and only digits, they're quite easy to remember, even though I sometimes still forget one of my PIN codes. But in theory, they're quite easy to remember. Which also is convenient with PIN codes is that they're usually used with something physical. So if you have a SIM card, you need a SIM card in combination with that PIN code. Same for your ATM card, same for that keypad next to the door of your apartment complex. A PIN code is usually used in a situation or a scenario where you have something physical mixed in with that PIN code itself. But because they're short, they're not so hard to guess. If they're easy to remember, they're also easy to guess. But the good thing is that usually you have 2 tries, 3 tries, and then they get blocked. So there's other ways of mitigating this risk of them not being too hard to guess. The next one is a pattern. We see this on Android phones. Who uses this on their phone? Cool, quite a few people. And most people that I ask about this, I don't have an Android phone, so I don't use it, but they use this because it's convenient. It gets into your muscle memory, and you don't even have to think when you want to unlock your phone. You just swipe the pattern that you've been swiping for 10, 20, 30 days, 1 year, whatever, as long as you've had that pattern. And under the hood, the pattern is just a combination of whatever the software engineer decided that it's going to be, and it's also just a password. And the good thing, like I said, it goes in your muscle memory, so it's very easy to remember. You can do it almost automatically. The bad thing, touchscreens often reveal the pattern as dirty spots because nobody cleans their screen after they've unlocked their phone, right? Nobody does that. And people often use their initial letter or the lucky numbers, so through some social engineering, you might be able to guess the pattern as well if you know the person's whose phone or whatever device that uses a pattern is. If you know them, you might be able to guess a letter because people are lazy. People like to remember what they already know. So initial letters, lucky numbers, things like that. So what's my problem with passwords? Let me show you. A simple username password field. And of course, from the first try, you never get it right. Nobody does. So you type a second time, and you try to log in, but I'm not very good with typing when there's people sitting in front of me. So third time's the charm, right? I log in again, nope. So what do? Okay, I forgot my password, so let me quickly reset my passwords. I reset my passwords, and when I click on reset, you get this nice message. We've seen this before. I've seen this before. Every time that I think I forgot my password, before I used the password manager, I usually just didn't manage to type because I was nervous, I had something on my finger, doesn't matter. But most people do remember the passwords, they're just not able to type them in correctly. I think that's my own conclusion of this. But passwords are very, very, very annoying. It's a very non-user-friendly way of authenticating, of proving you're right, that you are who you say you are. But if you use a password manager, and I think most of you in the room already said earlier that you do, they might help you remember passwords. So they are annoying. There's ways of you to remember those, like password managers, but it still requires an extra piece of software, something extra for you to remember those passwords. So it's still not the best user experience you could offer. And user data can get stolen. And I used to have a whole list of stolen user data in this slide deck, but I had to update it almost daily because, well, there's so many data breaches and data that gets stolen that I just took it out. And I just wanted to say that data breaches don't always include passwords. They sometimes do, they sometimes don't. And sometimes they also contain passwords in plain text, which if we learned from the earlier slides, please don't store your passwords as plain text. And the good thing is, if you use Alt0, we have a breach password detection functionality that warns both the user and the admin of the website of the application that somebody's trying to use in with a breached password, which is a password and username or email that's known to be compromised and in a list of breached passwords, and they will be forced to reset their credentials. We also just launched the Credential Guard, which is something that takes it a step further, which means that you get a dedicated team of security professionals that look all over the internet and the dark web for lists of breached credentials. But if you don't use Auth0, no worries. Things like Chrome, 1Password, most modern password managers and browsers do warn you or have the ability to warn you if you are using breached credentials. So, some tips for a good password. Length is more important than complexity. Use a reasonably long password. Don't use anything personal because people might be able to guess this through social engineering, and don't reuse passwords. And I know this is difficult for a lot of people, especially not people in IT who use 1Password for every service. Please don't do this because if they get leaked in one service, credential stuffing attacks will happen and bad people, hackers, will try to reuse your known leaked credentials with any service out there. So don't reuse your passwords, please. Cool. So let's fast forward a bit. And let's look at Passwordless. The first one, the one I think most of us have seen or used already, is one-time passwords. And they're valid for one-time use. It's in the name, one-time password. You can use them only once. And they often expire after a certain time. If you use the Google Authenticator app, for example, they expire after 30 seconds. It's usually a bit more, but they just give you fake timers, so you hurry up with those one-time passwords. But they're not valid forever. They will expire after a certain amount, depending on what sent you that one-time password. And they're often sent directly to the user in an SMS, in an email, through an Authenticator app, and so forth. So if we look at the one-time passwords which are sent in an SMS, if you use iOS and Android, your keyboard will usually just say, hey, I just received a one-time password in your messages. Do you want me to fill it in? It looks a bit like this. This is a second-factor authentication on GitHub, and you can see the message on top that I got a one-time password, and the keyboard says, do you want to fill in the one-time password from messages? I believe that Android has the same functionality, so this is really convenient. You don't have to remember your password. You get a password sent directly to you, and you don't even have to type it in because you can click on a button, and it will automatically fill it in on the application. But SMS messages can be intercepted, which means if somebody tries to intercept your message, they can use your one-time password before you do, and it's a one-time password, so they're in, you're not, and you're not in luck. And you need your phone on hand, so if you're upstairs and your phone is downstairs, you have to go all the way downstairs to get to that one-time password, which, if you're lazy like me, might be a challenge. The same thing goes for one-time passwords which are sent in an email. Just like with an SMS message, they're sent directly to you if you configured your email address right. And for example, Slack does this. They can send you a magic link, which is basically a link with a one-time password attached. You click on that link, and you're authenticated. No need to fill in a password. It's just sent to you directly through email. And the good thing is, usually we have mail configured on all of our devices, so you don't have to run downstairs to get your phone, because your mail is also configured on your laptop, for example. But again, emails can be intercepted. If they intercept your one-time password before you can use it, they're in, you're not. Lastly, an Authenticator app, something like the Google Authenticator or the Auth0 Guardian app, do all the same thing. They can generate one-time passwords for you, so you can just copy and paste them. And they're often time-based, or usually time-based, which means that they expired, like you can see here with the Google Authenticator app. Or they can be push-based, which means you don't even have to fill in that one-time password. You can just click on your push message and do allow or deny. Or if you open the app, you will also be able to deny and allow, which means that the Authenticator app takes care of this one-time password thing behind the scenes, and you just say yes or no, which is really convenient. But it relies on a shared secret between the app and the authentication service, which means that if that secret gets leaked, gets lost, gets stolen, anybody can pretend to be the Authenticator app and generate one-time passwords, which are valid as long as you don't find out that the shared secret has been stolen. So that's a vulnerability in this way of authenticating. Lastly, we'll see, social. Who uses social once in a while? Log in with Google, log in with GitHub, log in with something. I use it all the time, just because I'm lazy. And it's very convenient, because most of us have a Gmail or a GitHub or whatever you use, a Microsoft mail thingy. And it's one less password to remember for each service that uses it, because you log in with your Gmail, which means you know how to authenticate with Gmail, but the authentication then goes through Gmail with the third-party application, so you don't have to give them a password. It's one password less to remember, and it's one password less to be stolen as well. It also means that you give passwords to a service you trust. If I log in with Gmail, it means that, well, I trust Gmail to handle my authentication, even though they also might sometimes lose some data, who knows? But usually you choose the one you own, the one you trust, the one you want to use to authenticate. But again, you're relying on a third-party service for authentication, which means if they go down, your users can't authenticate. So be sure that there's always a backup way for them to log in. And one-time passwords are often used as a second factor these days. All these things that I just showed you, the one-time passwords in an authenticator app, in an SMS, whatever, they're often used as a second factor, but they don't have to be. You can use them as a first factor. For example, the magic link from Slack. It's a one-time password in a link, which is used as a first factor to log you in, not as a second factor. Cool. So let's get to the point. Let's get to the point where we don't have to use passwords anymore on the web. Let's see what the Web Authentication API has to offer to all of us. And if you're lazy, and we're all developers, so we're probably all a bit lazy, WebAuthn is the abbreviation of the Web Authentication API. So if you want to Google more information about the Web Authentication API, type in WebAuthn, you'll find more results. And WebAuthn, or the Web Authentication API, is a key-based authentication mechanism, which means it doesn't use a password, it uses a public and private key pair to authenticate on the web, and not that password. It also uses hardware authenticators, so it uses pieces of hardware or chips embedded in your devices that deal with nothing else but creating those private and public key pairs and using them to authenticate. And they look something like this. There's a whole bunch of them. You have them through USB, you have them through Lightning, through Bluetooth Low Energy, to NFC, which means that you should be able to connect one of these devices to any of your devices. If it's your phone which doesn't have USB because it's an iPhone, you might be able to use a Lightning or a Bluetooth Low Energy. And if you have an Android phone, you might be able to use an NFC while your phone is charging because you already occupied the USB port. So there's a bunch of those devices that can connect to most of our laptops and phones out there. Who has one of these? 10-ish, 15-ish people, very good, very nice. If you have them, please use them, they're very capable. And if you have one of these, our earlier login window will look something like this. We have my username, because I still have to tell the application, hey, it's me, it's Sam. But you don't have to type in a password. So what's going to happen is, I click on login, and my browser is going to ask me, can you please touch your YubiKey that's attached to this? I'm on localhost, so I have to allow it all the time. But once I've done so, I've used my YubiKey to authenticate on a website. I didn't use a password. My YubiKey has generated a public and private key pair and has used those to authenticate. How that goes, I'll tell you in a second. But we authenticated without passwords. The good thing is they're built into most modern devices, and all of us own one of those devices or more. Modern phones, modern laptops, all have a dedicated chip that can do exactly the same thing as those external roaming authenticated devices. So when I ask you who has one, everybody can raise their hand because we all own a laptop or a phone that's reasonably modern. So if you look at the same example again, we have a login form without a username, but instead of touching my YubiKey attached to my laptop, I'm going to touch the Touch ID, which my MacBook Pro has. If you have Windows Hello, it might use the face recognition thingy of Windows Hello. If you have an iPhone, it might use Face ID, whatever is built into your device. So my browser asked me, can you please touch your Touch ID? I did so, and we get the same result. We get the ID of a private key that has been generated together with a public key. So again, we logged in, we authenticated, using nothing but those private and public key pairs. Well, fake in this demo, but we'll see how that works in a second, and not with a username, which is pretty cool, right? So how does this work? Because it's not magic. There is something behind the scenes doing its job. And the first thing you need to do is create new credentials. It's the same if you register with a new application. You have to give them a password. You have to create credentials. When you want to use WebAuthn, same thing. You create new credentials, which are a public and private key pair that stays securely on that authenticator device, on your YubiKey, on your Google Titan key, on your chip in your MacBook Pro, whatever you have available. And once you say to your website, your application, hey, it's me, my username is Sam, and I want to register a new WebAuthn credential, it's going to ask the backend for a challenge. And a challenge is an array buffer with random data. You do this on the backend, so it's cryptographically secure. And you send that challenge, those random data, back to the browser, which will relay that to your authenticator device. And the authenticator device will take that, generate a public and private key pair, and sign that challenge with that private key. But before it does that, it asks for a user interaction. WebAuthn always needs a user interaction, whether that's touching your Touch ID, touching your YubiKey, whatever user interaction is built into those authenticated devices. It always needs to be one. Now, user interaction does not mean user verification. That's something completely different. Some do user verification, some do just the effect. They check that somebody touched it, that somebody is present, but they don't check the identity or the biometrics of a user. But both are possible. And once you've done this user interaction, it's going to send back the signed challenge with the public key and the private key ID through the browser, which you can then store in your database. And because it's just public key information and the ID of a private key, it's public data, so it's not sensitive. You can store it safely in your databases, and in the worst case scenario that your data gets breached, they have some publicly available data. A public key is something you can give to third parties, and the private key ID is still only the ID of the private key that's stored securely on your authenticator device. And once you're registered, you can use those credentials you've registered anytime you come back to those services to authenticate using WebAuthn. So the same thing goes for this scenario. You have your username, you pass it along to your backend, and it's going to see, hey, do you have some credentials stored for this username? If so, let's send back a challenge, those randomish array buffers, together with the ID of the private key that you've used before when you registered your credentials. Send them all to the authenticated device and sign that challenge using the same private key that you have the ID for, user interaction, and send it all back. And because you have your public key data stored in your database, you can verify that it's been the same private key that signed that challenge. So you can verify that it's the same authenticated device that signed that challenge. So it's the same person that tries to authenticate. So that's how you can authenticate using WebAuthn without passwords, but with private and public keys. So we're at a conference. I need to show you a little bit of code. We're at a PHP conference, so don't run away, because the first thing we do when we create new credentials is run some JavaScript, because it's a browser API, and browser APIs are always accessed through some JavaScript. And when you run navigator.credentials.create, you can give it some configuration, but in the end, it will generate that public and private key pair and do whatever it needs to do, sign the challenge, and so forth. And if you look at that little bit of configuration that you can give to it, the first thing, obviously, is a challenge, the thing we need to sign with our private key, the random array buffer, or the array buffer containing random data. Next up, we can tell it a bit more about the relaying party, which is your application itself. It's your website URL. You don't have to give it. It usually takes the one you're on already, and maybe the name of your relaying party as well. Some information about the user, what's name it is, a display name maybe, because a name and a display name is not always the same, and an ID, and this ID can be anything as long as it's not user identifiable. So it means that if you steal that ID, you should not be able to know who this is. Only I should be able to know who this is because I have a database with IDs or whatever. And some information about all of the algorithms that you know how to work with, because most of the authenticated devices can use a whole bunch of algorithms, but maybe you on your backend, you're more comfortable with a few. You can tell the YubiKey or the authenticated device, please use this algorithm if you're able to. And this is an array, so it just goes from top to bottom until it finds an algorithm that it knows how to use. And you can see that it's -7, which corresponds to ES256 in this list of algorithms. You can tell how much time the user has in milliseconds, so 15 seconds in this scenario for the user to touch their authenticated device, do whatever they need to do, and send back the credentials. And you can exclude some credentials. If, for example, you know that one of your credentials, your authenticated devices, has been lost. I lost my YubiKey here on stage, for example. I can put them on a blacklist, and I can exclude them so they won't be able to be used by somebody else in the future. And you can also tell a bit more about which authenticated devices you would like to support. So if you would like to support built-in platform or roaming, YubiKeys and whatever, which are cross-platform authenticators. If you leave this blank, both are allowed. The same thing if you want to verify the user, which is Face ID, Touch ID, something that verifies the user. You can also set this to preferred. You can also not just set this and then anything is possible. Just touching is not verifying the user, it's just verifying that somebody's there. And lastly, require resident key, we'll see in a second. And attestation just means if the attestation data which is returned from this YubiKey should be anonymized or not. Cool, so you can configure a lot of things. I'll give you a website later where you can play around with them and see what they all do exactly. But once you've created those credentials, you can use them the next time the user comes back and authenticates. And it's the same thing, navigator.credentials.get instead of .create, and you can give it a little bit of a configuration. The first thing, or challenge, the thing we need to sign. And then lastly, or secondly, the list of credentials we have stored in our backend. This is where you would put in the ID of the private key you've stored for your user, so we know the authenticated device knows which private key to use to sign the challenge. This can be multiple if you've registered multiple devices for your user. This is an array you can put in as many as you want. And lastly, again, user verification, yes or no. So that's all you need to know front end. It's quite easy, right? You just call 2 JavaScript methods and it should be working magically. But on the back end, you need to do a lot of things. You need to verify signatures based on public keys and private keys and all of that. So how does this work? The first thing, again, when you create a new credential, this is what you get back. If you run navigator.credentials.create, this is what eventually comes back from that API. And this is all the data you have to work with. What you see, firstly, is a raw ID and ID of the private key. This is so you can identify that private key in the future. It tells you which type, a public key, and it gives you a bit more information about the client data JSON and an attestation object. Those will not be in plain text. You'll have to decode those. But if you do so, the client data JSON tells you a bit more. We used webauthn.create. The original challenge that we signed is this one. You can verify that it's the same one you sent to your users. The origin on which website your user is doing this WebAuthn request, and if it's cross-origin or not. And the attestation object is a bit longer, but it contains the public key information you can store in your database to verify signatures in the future. It also contains a bunch of other things like flags. Did the user verify themselves? Did the user verify that it's themselves, not just the presence check, but also a user identity check, and things like that. So when you validate the returned authenticated data, the first thing you're going to do is check, is there a private ID key? Because if there's no ID key, well, a key ID, sorry, you cannot use that key in the next time the user comes back. Next up, you will validate the returned client data. Is the challenge the one that I send it? Is it not being intercepted in the middle and changed somehow, which should not happen, but you never know. Is the origin the one that is intended for, and so forth. Next up, you validate returned attestation data. Is the user verified? Because I want only verified users, not only presence checks, for example. You can do some more checks if you like to be quite strict on the back end. And lastly, you save those credential IDs and the public key information in your database. And when you verify an existing credentials, this is what you get back. You get back the signature, which is a signed challenge for a user handle, and a bit more information. We did webauthn.get this time, but not that much information for a authentication request. So what you need to do here is validate that the user, the challenge, and the origin are the ones that you're expected to be, and validate the return signature based on the public key information you've stored in your database. And this is actually going to be the part where you authenticate a user, because you can verify that the exact same or the right private key has been used based on that signature and the public key information. Cool, we're almost done. I promise we can almost go drink beers, but I want to tell you a little bit more about resident credentials, because I don't only hate passwords, typing in my username is sometimes too much of an effort. And luckily, the very smart people who came up with WebAuthn, which is based on CTAP and a lot of other things, FIDO2, also figured out a way that maybe in the future we don't even have to type our usernames, but our browser will ask us, hey, is this the username you want to use? Because they can see that you have a profile for that user stored on your authenticator device. And you can do this by just setting requires resident key to true when you register a new credential. And let's see it in action. I cannot show this in my slides because it doesn't work on localhost. But if we go to webauthn.me, which is a website we have created with Auth0, you can see that we have a debugger where you can play around with all of those configuration things that I talked about earlier. And if I fill in PHP, that's not PHP, PHP UK, and my display name is elephant. And we enable requires residence keys, and all the rest will just leave as default. We are going to create a WebAuthn credential or credentials for this website, webauthn.me. So let's do so. I'm going to use my YubiKey attached. This one is PIN code protected for second factor authentication. Touch it again, and I've registered these credentials. Cool. So now we can authenticate without even having to type in a username. If we go to the Authenticate tab, it will remember everything we've done in the previous step. And instead of sending along an array of allowed credentials we saved in our backend, we're just going to say, figure it out yourself, browser. Check if there's some saved credentials on the authenticated devices available to you. So when we do this, let me increase the timeout a little bit. We'll see that the browser asks us to choose one. This one has a PIN code, like I mentioned. Touch it again. And you can see that there's a bunch of credentials saved on this authenticated device. So now I can just choose the PHP UK one that I created earlier, authenticate, and we get the output we were expecting. So you can just not only save public and private keys, but you can combine them with user information, so you don't even have to type them in yourself, which is cool, I think. No? I think so. So, what are the benefits of WebAuthn? First off, public key and private key-based authentication is usually more secure than a password-based authentication because the private keys are stored securely on those authenticated devices, and the only thing that comes off of it is public information, the public key, and the private key ID. Also, it's phishing resistant because it's based on the origin. If I create credentials for webauthn.me, if I create credentials for google.com, those credentials will not be available to any other origin. So you saw that I had a list of credentials stored when I just did the demo for webauthn.me. If I would do the same thing on a different origin, on a different website, on a different domain, that list would not have popped up because those credentials are created for webauthn.me and not for any other service. It's phishing resistant. You only store public key data in your database. Again, you store the public key and a raw ID, or the ID of a private key, not the private key itself. And you find great control of which credentials to allow. If you prefer roaming ones, the ones that you can attach, like a YubiKey, or the built-in ones. If you prefer user verification, and so forth, and so forth. You can quite well control which kinds of credentials you would allow your users to use on your application. And they offer a better user experience because the user either has to type in their password and touch their Touch ID or Face ID or YubiKey, or not at all. They just select the profile they want to log in with on your application, touch the Touch ID, Face ID, whatever, and they're logged in. And lastly, no more passwords. This is Dugout Passwords, no more passwords. There's still a few issues to be solved with WebAuthn. The first one is user credential management. I have a bunch of credentials stored on this YubiKey that I use for the demo. I cannot manage them. I can either delete them all or keep them all, but I cannot say I want to remove this, and this credential from it yet. Google has an option that should be able to allow you to do certain things in Chrome, but I've never been able to get it to work. If you use YubiKeys, you can erase the whole YubiKey, which means all credentials will be erased, but you cannot choose certain credentials and keep others, so it's an all or nothing scenario. I'm pretty sure that one day soon this will be solved, but for the moment this remains an issue when using WebAuthn or FIDO2 or any CTAP-based authentication mechanism. Also, cross-device credentials. These credentials are stored on your device, on your chip, on your YubiKey, whatever. So if I register credentials on this MacBook Pro, I cannot reuse those credentials on my phone, for example. What you can do is either create two credentials, one on your phone and one on your laptop, or use a roaming one like a YubiKey that works with Lightning and USB-C, for example. So I can use the same YubiKey for both my phone and my laptop. But you cannot get the credentials from an authenticated device and transfer them to another. They will stay securely on those authenticated devices. So if you lose your authenticated device and or it gets stolen, that might be a problem. So when you use WebAuthn, always have a backup, always have a way for users to authenticate, to recover their profiles. This might be a password. This might be like GitHub has these phrases that you can put in or whatever. Just always you need to have a way that users can authenticate without their WebAuthn credentials because, well, they're on a physical device. Physical devices break, so they need to be able to recover their accounts. So WebAuthn might replace passwords. I think they will in the future. For now, all of us still type passwords, but they might replace them. But they will not replace token-based authentication or authorization, things like OAuth or OpenID Connect, and they will not replace identity providers. I put this in there because I get this question all the time. No, they will only replace passwords. That's the only part in the authentication process that they will replace, the actual password part. So it's a W3C recommendation, which means it's available in all modern browsers. And you can use it already on most major services, sometimes only as a second factor, sometimes as a first factor. If those services use Auth0, they can use it as both first or second factor. For example, you can configure a roaming or a platform WebAuthn key as a multi-factor authentication, so as a second factor. Or if you have an enterprise subscription, you can also do it as a first factor, where your user would still register with a password, but the second time they come back, we will check, or when they log in the first time actually, we'll check if they have a device available that does know how to do WebAuthn, an authenticated device, and ask them if they want to register this and use that one from that point onwards. So they will register their password as a fallback, but from that point onwards, they will be able to use WebAuthn. It's still not very readable, but it's the middle flow. If you want to see more, we can look at it later together. WebAuthn.me is a website I used before, which had the debugger. It also has a bit more information about WebAuthn in general, and a nice interactive tutorial that lets you see the back and forth between the authenticated device, the browser, and the backend. It's fake. It's just illustrative, something like this. It illustrates what's going on, but it's somehow it's nice if you want to see the back and forth between a browser. That's usually going to happen when using WebAuthn. So let's summarize. Boo passwords. That's my own summary because boo passwords. WebAuthn.me, the specification is quite readable as well if you like to read specifications. Our blog is full with articles, and these slides will always be available at 1990.sambega.tech. Thank you very much for listening.
Yeah, thank you, Sam. This was really, passwords are so old. Yeah.
Yes.
Any questions?
How well supported is WebAuthn in kind of browser testing tools like Selenium and WebDriver and things? Like, can you do integration tests with it?
So if you use Selenium, you use a browser under the hood anyway. And WebAuthn is a browser API. It's built into the browsers. So if you use Selenium to test with Chrome, it will be available if your Chrome version that you've specified for Selenium has WebAuthn. Same for Firefox and so forth. So it should be quite well supported.
Anyone else?
There's one question over here in the corner.
How would you go about migrating from having passwordless to going to WebAuthn, etc.? What would be the best way to introduce it to users who wouldn't be developer savvy?
So how would I migrate from a passwords scenario to a WebAuthn scenario, right? Where you already have users registered with a password and you want them to use WebAuthn, correct?
Yeah.
I think that's the same scenario like what we do at Auth0 is you still register your user with a password and then you ask them, do you want to use WebAuthn? You might put it in a more user-friendly term like, do you want to use your Touch ID to log in next time, which most of the mobile apps do, instead of asking, hey, do you want to use WebAuthn? Because nobody knows what that means. But you can just, whenever the user logs in for the first time, or whenever you've implemented WebAuthn, they log back in, you can ask them, hey, do you want to use Face ID, Touch ID, whatever you have available on your device? Next time you log in, they click yes, you do everything behind the scenes because in theory they should not have to do anything else except clicking yes. And they can use WebAuthn the next time they log in. They can also still use their password if they don't remember choosing WebAuthn as an option, but you can always ask them. Does that make sense? Just ask your users and make it user-friendly, like do you want to use your Touch ID like you use in every mobile app, for example.